Let's talk about core concepts of memory in PLCs. In general, this lecture is going to cover the core concepts and not be too specific over one sort of brand of PLC, because most of these concepts actually do exist in most of the PLCs that you do get. So having a look at one of the data sheets for the SS2 series and Delta, we can see on this list there are quite a few different types of memory bits and memory registers that we can actually use to store data and even states within inside our PLCs. So having a look just at the very first one, this auxiliary relay, which is this M register. If you remember correctly from our previous lecture, we used the memory bit to turn the memory bit on and then give an output to another memory bit. So these memory bits can actually be used to hold states within our program without actually affecting the physical outputs on the PLC or the inputs as well. So there are a few different types of memory bits that you get. So in this case, we've got the general memory bit, which we can use for just storing temporary values. So what this would mean is that if the PLC had to power down, we would actually then lose the state of these memory bits. Here you can see the range of the memory bits, where they actually sit in the PLC. The next one is latched, or what we usually call retentive memory. In the case of Delta, we call it latched, but in most PLCs we talk about retentive memory and registers. These registers usually have more retentiveness and they retain their state even when the PLC is turned off, so that the next time it actually starts up, we can start the PLC with those states once again. So just a few other things that we need to note here that we've got the special memory bits. Often these are used for settings within the PLC. These may differ from PLC to PLC, but usually the information is quite easily accessible and you can just find out what each of the memory bits actually mean. So moving further down, we've got the T memory bit, which basically stands for timer. So there's different types of timers. In the case of this data sheet, we can see that timers T0 up until T126 run at 100 millisecond intervals. And if we do set memory bit 1028 to on, then we will get a 10 millisecond delay between increments of the timer. Whereas here we've got M1038. If that is on, then the range of T200 to T45 will have 1 millisecond. So you can see how some of the special memory bits that we have, we can actually then toggle options on and off in our PLCs and actually then affect other registers as well. So these sorts of things are very important to actually note, because often you get a lot of bugs in your programs, and it's sometimes that a special register is being used somewhere and turning on options which are actually causing bugs within your programs. So just keep that in mind when writing your programs so that you don't run into this problem down the line. So next we've got counters, which have 32-bit and 16-bit counting ranges. So this means we can count up to really large numbers in the 32-bit range, which is close to the 2 billion mark, and the 16-bit range is a lot smaller, but the 65,000 sort of mark where we can count up to and store. So moving down, we're not going to be talking about step points at this point in time. We may cover this in this course later on, but the biggest and most important registers really that you need to know about is the data registers, because we would usually store some data values in there, which will be like settings for our programs. Maybe we've got a very specialized machine which must contain some settings like lengths and other sorts of values which we need to do measurements on and comparisons on in our programs to actually cut certain items to length or whatever the application may be. So these word registers are very important in storing our data. So once again, they also have general and latched, where we can then retain information over a longer period of time. And with addition to this, we have two different types essentially. We've got double word and we've got single word registers. So if you look at this general, you'll see the *1, which basically means it's a single word data register, and here we've got *2, which means it is a double word register, which allows us to just store larger amounts of data and bigger numerical values. In the indexes, what we actually use these for is to keep indexes of where we actually do store data in our data register so that we can then retrieve it and actually start reading data from specific indexes and using that data to our advantage. So where we typically use these sorts of indexes is when we have programs where we store multiple sets of data for different configurations, and all we can really do is then just increment our index and then load up the next set of values for our settings for our program. So indexes are very useful, a bit more of an advanced topic, but definitely can be incorporated into your programs to actually get data that you specifically need for a particular task. So that is basically the idea behind data registers and memory management. Just keep in mind when you are writing your programs that you do use retentive registers in the correct places so that when you do need more memory for storing actual information later on, that your data registers aren't overlapping with general registers which you should have used for just storing temporary information. Show you in a later lecture how we can actually check which registers we've already used in our program so that we can make decisions on what registers we can use next in our programs. But for now, I think this is a good introduction to how memory works in PLCs. And as I said, most PLCs have this retentive latch sort of scenario, and also the general purpose registers which do lose their data when PLCs are powered off. So I hope this has been useful, and see you in the next lecture.